In this lesson, what we're going to do is talk about forces on an inclined plane. Before we do that, we'll do a quick recap first on forces so far. So, if I give you two examples here, we need to figure out what the net force is. If I have 6 newtons going to the left and 6 newtons going to the right, what will happen? They will subtract, right? They're in opposite directions, it becomes 0. If I have another example here, 8 newtons to the left, and then I have 4 and 4 going to the right, two forces. Well, you'll add these up, that'll become 8. 8 minus 8, again, that becomes 0. Here is another example. A force of 16 newtons accelerates 8 kilogram block at 4 meters per second squared along the horizontal surface. How large is the kinetic force of friction? Kinetic force, friction force, too many words. But yeah, the general rule that we use is, if you remember, F net, which is all the forces, F net equals MA. So we have the force that we're using, so the force is the applied force, so F applied, I can say, minus friction, all right, Fk because it's kinetic, that equals to MA. We can now substitute some numbers into here. I have 60 minus Fk, which is what I'm trying to find, equals MA. That's 8 times 4. If you write this much, and at this point you use Shift Calc on your calculator, you can directly get the answer. You'll get it correct and you'll get the full marks. Don't forget to write the unit, forces in newtons. If you solved it, of course, F minus friction equals 8 times 4, like we said. 60 minus friction equals 32. Rearranging now, I have to move the F to the other side. I'll take the 32 to the other side. 60 minus 32 will give you 28. Or Shift Calc will give you the same answer. So that's a way to find the friction force. What did we do? I'll close this off, that's confusing. Let's do this. Start with F net equals MA. Break the F net into the different forces. We have two forces, applied and kinetic, equals MA. 60 minus Fk equals 8 times 4. Of course, 8 times 4 is 32, so I can continue by doing that. 60 minus Fk equals 32. Rearrange to get 60 minus 32 will give me friction. Amazing. All right, so forces on an inclined plane. An inclined plane is simply a slope. You put something on a slope, obviously it will go down the slope. It is a type of simple machine. We don't really need to know all the different simple machines. There are levers, pulleys, wedges. We just need to know the inclined plane. It makes life easier for us. If I wanted to move an object to a certain height, I can use a ramp to do it. It's been used in many, many different situations, like in wheelchairs, loading boxes, even when you're trying to move ships into the water and out of the water or whatnot. All of these things are applications of inclined planes. So, if you have a box on a slope, we of course know gravity is pointing directly down. But it's not falling straight into the slope. It's falling in this direction, so we call that F slope. A component of this gravity is going down the slope. We also have the normal force. The normal is always perpendicular to the surface. So here's my surface, it's going to be perpendicular to it. That's my normal. You can see it's kind of making a little triangle on this side over here. We have this slope, this arrow is exactly the same as this arrow. So this is the same. I can make a little right-angled triangle in here, and I can calculate whatever I need to find. If I used SOHCAHTOA, and I wanted to find the opposite. Here is my angle, that means this is my opposite of my angle. What do I need to use? This is the opposite, and this would be my hypotenuse, and then this would be my adjacent. O and H would of course be sine. So, sine is this F slope, remember this is F slope, divided by mg down here. This is going to help us get our first formula. F slope, take the mg to the other side, it becomes multiply both sides by mg, and I have my first formula, F slope equals mg sine theta. That's the first one over here. If I wanted to find the normal force, which is the adjacent, that's A in H. So I will have to use cos for that one. A in H, F normal over mg. Rearranging, F normal is mg cos theta. This will be needed if you need to find friction, the kinetic friction, for example, because we use FUF. mu multiplied by the normal force. So we will maybe need to use this to find it. Okay, so long story short, you need to know two things. You need to know the weight down the slope, mg sine theta. Weight perpendicular, mg cos theta. Every time, every single time. Just memorize it for now. You can forget about it after the exam. But this is it. You don't need to derive it. You don't need to create it. You just need to know those are the two rules. So, just to keep in mind that the weight is directly downwards. Only a component of the weight is going down the slope. So we are splitting it up. The bit that's acting down the slope, the most important force, is the mg sine theta. That's how to find the component of the weight going down the slope. W equals mg, and then we're adding the sine theta because there is an angle there. There's an example. A block of wood with mass 2 kilograms is placed on a slope with a 30-degree angle. If there's a friction of 4 newtons acting on the block, what is the unbalanced force down the slope? I'll quickly draw it for you so you understand what's actually going on in this case. What we're doing is we're having a block on a slope like this, and this angle is only 30 degrees, and then here is my block, and this is my F slope, and then we have a friction force. We do not need to calculate it. We don't need to do the mg cos theta because I already have it. It is 4 newtons. This is my friction of 4 newtons. I need to find this, and then I can just subtract the two because they're in opposite directions. I will do mg sine theta. What is my m? M is my mass. This is my m here, 2 kilograms. What is g? Well, that's gravity. mg, 9.8. So 2 times 9.8, sine 30. Sticking that into your calculator, you should get 9.8 for this. Then we'll just subtract the two. 9.8 minus 4 will give us 5.8 newtons going down the slope. This small un simply means unbalanced. You don't need to write it. You can just write F net or F or whatever you want to write. It's not a problem. Here's another example. Now we need to find the magnitude of the normal and then the acceleration of the block. For the normal, we'll use mg cos. For the acceleration is, of course, A equals F over m. Remember the rule? A equals F over m. This is the Newton's second law. This F is not the mg cos. This is the force pulling down the slope. The acceleration is going down the way, so I will use mg sine theta for that. If we get through the question and the calculations, just to speed things along, to find the normal, mg cos 2 times 9.8 times cos 30, 16.9. That is there. Then I'm doing the mg sine theta. So what I can do is A is F over m, like I said to you earlier. Mg sine theta divided by the mass, which I know is 2. So 2 times 9.8 times sine theta, which is 30, divided by the mass again, which is 2, and that gives me 4.9 meters per second squared for the acceleration. There you have it, nice and easy. Another quick question, what is the net force in this here? So what's going on? We've got a bunch of forces here. Gravity is pulling down, but of course the block is not moving down. It's broken up into two components. We have this one here. This is going to be parallel to the slope. This means parallel, F slope. This is perpendicular. That means perpendicular, 43. Well, the normal and that will cancel. We have 25 and 20, subtracting them. So you'll have to do 25 minus 20, which would be 5 newtons going down the slope, like going in that direction. That's it. Keep vocabulary here for you. Parallel, same direction. Perpendicular is 90-degree angle, so that's what you need to remember. Parallel is the same direction of the slope. Perpendicular is at the 90-degree angle, which is the normal force in this case. So, quickly recapping this, the greater the angle of the incline, the faster it will slide down the incline. There's always at least two forces acting on the incline. You have the normal force and the gravity force. You will have a bit of friction as well sometimes, and you would have to calculate that using FUF from the previous video. Thank you.